Well, let's look at another example before we get to the inverse function theorem. Suppose that f of x has an inverse function g of x, which by definition would be f inverse of x, but I'm initially going to use g just because it makes the writing a little bit less confusing. Well, as we know from inverse functions, if they're in fact inverses of each other, then g of f of x is equal to x, because essentially they undo each other. F does something to x, and then g brings it right back to x. Takes that value of f of x, and when you put that value into g, it just brings you right back to x. For example, multiplying a number by 3 and dividing a number by 3. If you apply both of those, you're going to end up with the same number you started with. Okay, well, what does this mean? That means that the derivative of both sides, that means the derivative of, we can take the derivative of both sides, and we still have an equation here. And I'm going to go out one more to the right. We know what this is by using the chain rule. It's g prime of f of x times f prime of x equals 1. The derivative of x is just 1. All right, well, that tells us that if we just rewrite that a little bit, I could get, well, which one do I want to use? I will use the f prime. If we want f prime of x by itself, we get that's equal to 1 over that. And let's see, I could also write that as g prime of f of x is equal to 1 over f prime of x. This actually is what the inverse theorem, inverse function theorem looks like. And doing some substitution, I could say, go back to f inverse, because g is f inverse of x. So g prime would be f inverse prime of f of x equals 1 over f prime of x. And again, that's essentially what our inverse function theorem says. All right, well, before we formally introduce that inverse function theorem, let's do a little simple example. Let f of x equal e to the x. Now, hopefully you remember what the inverse of e to the x is. And if you don't, we can just go back and do the 4 steps to find the inverse function. Step 1, y equals e to the x. Just replace f of x with y. 2 is interchange x and y. So x equals e to the y. 3 is solve for y. Well, how do we solve for y? Well, we can just write this like a log equation. Or the way I like to think of it is take the ln of both sides. If x is equal to e to the y, then ln x is equal to ln e to the y. But the right-hand side just gives you y. So number 4, the inverse function would be ln x. Okay, so we have a function and we have its inverse. Let's take the derivatives of both of those. F prime of x is, well, that's a nice function. E to the x, the derivative is e to the x. G prime of x, the derivative of ln x is 1 over x. So let's just ask ourselves, does f prime of x, right here, equal 1 over g prime of f of x? I'll put a question mark there. Well, let's see. F prime of x is e to the x. and 1 over, here's g prime of x, but I need to plug f of x into it. So I'm going to get 1 over e to the x, which in fact is exactly equal to e to the x. So it works.